Good morning, everyone. Present here. Today I'm going to start with the chapter Electromagnetic Wave. Let's get started. I will first give you an intro about this chapter. This chapter is basically a short chapter, but it has lots of formulas. So you make sure you know that you remember all of this because there are some good questions which come directly on the basis of the formula. So let's get started. I will just give you the gist of it. Okay, let's start. EM wave. What does EM wave mean? It is a wave which is produced when a charge is accelerated along a axis, and it produces a electromagnetic field which are perpendicular to the direction of propagation and also perpendicular to themselves. You understand? I will tell you with a diagram. Just think, if this is the direction of propagation of the charge, then this will be the direction of propagation of magnetic field, and this will be the direction of propagation of elect magnetic field electric field, sorry. So they will be mutually perpendicular to each other. So if this is the direction of propagation, we denote it by z. So waves means electromagnetic waves. Let's get started with the chapter. First, I will tell you the source of EM waves are there are two sources of EM waves. First is accelerated charge. If this is a charge and I am accelerating it with some energy, then EM wave is formed. Or the source of electric field EM waves is also dipole, electric dipole. So this will be positive and let this be negative. Let's get in front forward. Sorry. So let's read. Light is an electromagnetic wave. As we all know that before lots of before modern physics, everyone used to think that light had a particle nature, but then we came to a conclusion that light also has a wave nature. So we define light as a electromagnetic wave which has a speed of 3 into 10 is to 8 meter per second. It's like the fastest of everything in this world. Yeah. Electromagnetic waves generally in free space move with the speed of light. Free space here it means vacuum. So the speed of light is the speed of waves when it is kept in a vacuum. You can see this, and the speed of light is, you must know by now, that it is 3 into 10 is to 8, 10 is to 8 meter per second. So this is the speed of light in vacuum. Yeah, EM waves, while they are in motion, radiate energy, transmit energy. That's why the electromagnetic field is formed. At the source of EM wave is accelerated charge. With accelerated charge, they produce sinusoidal, perpendicular to each other fields. Okay. Then we have electromagnetic waves propagate through free space. Yeah, they will always propagate through free space. The contribution of electric field and magnetic field to the total energy is same. That is 1 is to 1. If so, if the total energy is ET, it will be always equal to the sum of electric field and magnetic field. And it will be always in the ratio of 1 is to 1. In the EM wave, electric field is perpendicular to B, and also the direction of propagation is also perpendicular to both of them. So these are the conditions for a electromagnetic field to be generated. So let's get going. The speed of electromagnetic wave, yeah, this is one of the most important formulas. Some ratios are asked based on this. So it's like if a electromagnetic wave is kept in medium A and it moves with the speed of VA, and it is kept in free space and it moves with the speed of light. Find the ratio between them. These types of questions are asked mostly on this topic. So this is actually important. Okay. So let's go forward. Yeah, here in the formula, mu represents the permeability of a medium, and E represents the permittivity of the medium. Permittivity is the electric property of medium, which actually tells us that how the metal or the thing will react when it is, like exposed to a electric field. Same with permeability. It tells us it like magnetic property of a substance. It tells us that how a substance will react when it is exposed to a magnetic field. Yeah. Yeah, when you replace this mu and E with mu naught and epsilon naught, then it becomes speed of EM wave in vacuum, and it is equal to this speed of EM wave in vacuum is equal to 3 into 10 raised to 8 meter per second. You know, this is the speed of EMF in vacuum. Hmm. Here in this formula, mu naught is basically permittivity of free space, which is permittivity of vacuum. This is 4 pi into 10 raised to minus 7, as you will know from the lesson containing magnetism by Oort law. There you will get this value, and epsilon naught you will get this value in the charge as electrostatics chapters. You know, so you must remember these values. These are standard values because they are very important to be remembered. You know, to be kept in mind. Yeah, that's what I said. The speed of electromagnetic wave in vacuum is equal to speed of light, 3 into 10 to 8 meter per second. Then comes the Maxwell's displacement current. The Ampere circuital law, which Max Ampere had given before, it used to say that the surface integral of magnetic field, you know, it is equal to mu naught times I current flowing to it. But here he only considered the current flowing through the wires, which was known as conduction current, you know, conduction current. But but when Maxwell, you know, he's a big scientist and had lots of contribution to the electromagnetic theory. So when Maxwell was doing research, he found out that when he had put, you know, a capacitor between the circuit, he found out that the current was also flowing through the wires and also flowing through the plates of the capacitor, even though there was no wire kept between the plates of the capacitor. You can see, just imagine, this is wire and this is capacitor, you know. Okay, so this is a capacitor, wire and capacitor. So the current was flowing through this wire, and that was known as conduction current. But the current was also flowing between the area of this thing, you know, capacitor, and Ampere had actually ignored it. And this electric current, which was flowing through the plates of capacitor, without, you know, help of the wire, was known as displacement current. So this was given by Maxwell. So what he did, basically he corrected the equation, and, you know, the law is known as Ampere Maxwell law. So it is surface integral of magnetic field is equal to mu naught times IC plus ID, where IC is the original conduction current flowing through the wire and ID is the current flowing through the plates of capacitor. You can see the definitions of conduction current: current flowing in the conductor, displacement current produced by time varying electric field. Yeah, the formula of, yeah, this is important. The formula of displacement current is epsilon time d phi e by dt, where phi is electric flux and epsilon is permittivity of free space. Magnetic flux is denoted by B into A cos theta, or B dot A product, you know, B and A dot product. Yeah. Displacement current and conduction current together form a continuous motion. So, you know, if we had followed Ampere's law, then we would have find that the current was discontinuous because there was no current between the capacitor as stated by Ampere. But when Maxwell did the research on it, he concluded that IC and ID formed a continuous motion. So the formula to after all these, you know, equations, when they view add them, we get surface integral of magnetic field over any current loop is equal to mu naught time IC bracket, okay, bracket IC plus epsilon naught times d phi by d phi e by dt, and which this is known as ID, which is displacement current. Uh, and then we have some equations which was given by Maxwell. They define the electromagnetic theory of the, you know, they define the electromagnetic theory. That is all, you know. So first is surface integral of E through a surface area is always equal to Q by epsilon naught. This is known as also Gauss theorem. You must have learned it in electrostatics. Then we have surface integral of magnetic field across a surface is always zero. You must have known it, you know, by now. You just remember this formula. There is nothing a lot to, you know, be said about this. And then surface integral of B dot dl is equal to minus d by dt of B dot ds. So if this value won't come because this is surface integral. Most people make this mistake here because it's surface integral and it is direct integral. So make sure You don't make this mistake. So you basically what you do, you have to do this is equal to magnetic flux. Okay, so this is equal to phi b. So remember that. Okay, let's go in front. Let's go forward. Surface integral of BDL is always going to give you mu naught times epsilon naught d by dt into BDS. You must know this. This is phi e. So this is actually Maxwell Ampere law. So this will become Maxwell Ampere law. This is conduction current, so should come. Should be D, and this is displacement current. But the presentation is different, so don't get confused. Then we have Lorentz force. This force is basically the sum of force exerted by electric field and force exerted by magnetic field. So the force exerted by electric field is equal to QE, is equal to QE, and the force exerted by magnetic field is QVB sine theta. So we just add this equation and we get Lorentz force. This is known as Lorentz force, and along with Maxwell's Ampere equations, it forms the basis of electromagnetic wave theory. So let's go forward here. Does the representation of any wave is Ez not Ez? It's like Z is the direction of propagation. Ez not, this is known as amplitude, and then we have phase difference omega t minus ky. Same for the magnetic field, but it will be perpendicular to this thing. So if you want to take it as y, you can take it as y also. But I have taken x because they are also perpendicular to each other. So you can see the formula. W is 2 pi v, which is known as nu, which is known as angular frequency, and the ratio of this whole W upon small k is going to give the speed of light. So you must remember this formula because there are several questions where you will be given this and you will have to convert. Let's go forward. EM wave spectrum. You must know that the spectrum was formed when we collected lots of samples of this, and then we formed the spectrum. So the way there is a mnemonic which we used to remember this. गाड़ी एक्सयूवी वाली आए बड़ी महंगी रेट पर. सो गाड़ी गाड़ी जी, गामा रेज एक्सयूवी एक्स रेज, यू यूवी रेज एक्सयूवी. ओके, वाली विजिबल रेंज, आई आई इंफ्रारेड, महंगी माइक्रोवेव, रेट पर रेडियो वेव, रेट पर पावर वेव. सो दिस इज हाउ यू रिमेंबर इट. Thank me later. Okay. Then we have energy density and intensity. This is very important formula. This is not that important, but these two formulas are actually important. So this is energy density of. So this is energy density of uh, given by the electric field, and this is what is given by magnetic field. So B and E. So the total energy density of the substance will be given by half. You will add basically both of them, and then you can take this dV. This dV with common, and then you put it down there. So ut upon dV, ut upon dV will become total energy density. So this is the formula. U equal to half epsilon naught E naught square, and the representation. You don't have to remember the formula. Just remember the average. So if you want to find average, energy density, you will get 1 by 4 epsilon naught into E naught square upon 1 upon 4 mu naught B naught ka square. E naught equal to CB naught, and mu naught epsilon naught equal to 1 upon C square. Mu naught equal to 1 upon epsilon naught C square. You must remember this formula. There are conversions I have written here. You just see and read through this. Okay. C equal to epsilon naught upon magnetic field naught, that is B naught. You must remember this. This is also an important formula. Hmm. So what we do here, we put the equation C equal to 1 upon under root of mu naught and epsilon naught, and then we substitute the value from this equation, so we'll get the answer. So don't take tension anymore. Yeah. Electric energy density is always equal to magnetic energy density because the energy, given by both of them is equal. That's why they will also it will be also equal. Okay, equal होंगे ये भी. Intensity. Intensity is a very important formula. So wait. Yeah. Sorry for the disruption. We will continue from the part intensity. So let's consider a conductor which has a cross-sectional area of A and the length is L. So we can write distance as speed into time. So we have written it as C into delta D. C is speed of light and T is the time taken. Obviously, the speed of light is so fast that the time becomes very small. So delta T is considered. So what is intensity? It is energy density upon A delta T. Sorry, it's not energy density. This is the biggest mistake. U is potential energy. So we have found that potential energy is this. So potential energy upon A delta T. So we have to make this formula and you will get energy density into C as the last formula result. Remember this formula I equal to एनर्जी डेंसिटी इंटू सी वेरी इंपॉर्टेंट फॉर्मूला स्टार मार्क कर लो इसको आंसर आ जाएगा इजीली इसमें आई इक्वल टू हाफ एप्सिलॉन नॉट ई नॉट स्क्वायर सी और हाफ हाफ बी नॉट स्क्वायर बाई म्यू नॉट सी ओके इतना याद कर सकते देन वी हैव मोमेंटम सो द मोमेंटम ऑफ अ electromagnetic wave is given by p equal to u upon c wave completely it is the momentum when the wave is completely absorbed by a surface and p equal to 2u upon c because it will become when the wave is reflected back completely 100%, then we will have momentum equal to 2u by c because the distance travel is also double. Atmosphere. I think this is not that important part, but if you want to read this, I will tell you. Atmosphere is like 300 किलोमीटर के एरिया में स्प्रेड हो रखा है. इसमें सबसे पहला आता है ट्रोपोस्फियर विच इज एट द हाइट ऑफ 12 किलोमीटर फ्रॉम द ग्राउंड सरफेस ऑफ अर्थ. Stratosphere. This is the one of the most important layer. Here you can never detect climatic changes. That's why most of the planes, they travel to stratosphere. And then we have mesosphere at height 50 to 80 kilometer. Ionosphere, which is above the mesosphere. Okay. Density of air. This is an important result. Density of air, it decreases as you go up. That's why when we, visit mountains, we start to feel suffocated. That is the reason because the density of air, the mass of everything decreases and thus density also decreases. Properties of EM wave. This is like basically the recap of the whole chapter. So we'll do that. They are transverse in nature. Yeah, they are transverse in nature. Electric field is perpendicular to magnetic field, which is also perpendicular to the propagation vector. So basically, we can also conclude that Z is also perpendicular to E. Okay, so this is the thing. And the speed of light in vacuum or any EM wave is given by this in vacuum. Okay, and if it is any general medium, then you will use this formula, which can be altogether it will be written as mu naught into mu r, where this is relative permittivity and this is dielectric constant or relative, sorry, this is relative permeability and this is relative permittivity or dielectric constant. So epsilon naught is relative permittivity or dielectric constant, so this should be I think r. Okay, this should be r and this will be relative permeability. So we will get the equation as c upon mu r into epsilon naught er. So there are questions based on this. Okay, so make sure you remember this. Yeah, it can also be written as the speed of light upon refractive index of the medium. So the refractive index of water is less than refractive index of the glass. So as we increase the value of refractive index, the speed of the light altogether will also decrease as it passes from rarer to denser medium, and it will increase when it passes from denser to rarer. Mu r is relative permeability and epsilon r is relative permittivity. Then we have pointing vector S, which is given by cross product of electric field and magnetizing field. It represents the direction of energy flow per unit area per second along the direction of wave propagation. Okay, so basically it represents the direction. Okay, डायरेक्शन बताता है एनर्जी फ्लो का पर यूनिट एरिया में. ठीक है, ये बताता है पर सेकंड टाइम के साथ साथ. यूनिट इज वेबर मीटर पर मीटर स्क्वायर. Medium offers a hindrance to wave propagation. That's what I said. If there is a medium with high value of refractive index, it will always try to, slow down the speed of light or the waves. That's why the speed decreases. Such process is known as wave impedance. Impedance is like resistance. You must remember that from alternating current. So it is given by Z equal to E upon H. You must be remember magnetizing field, electric field equal to mu upon epsilon, which is altogether given as this formula. Not but then not that important. For vacuum, it is the value is important. Okay, the vacuum, the value is 376.6 ohm. This is the unit of Z, which is wave impedance. It is similar to resistance, analogous to resistance in electrostatic. So when you substitute E upon B as E upon you mu naught H, you will get this formula. At the end of the whole derivation, you will get this result. Important result. E upon B is going to give you C. Okay, so E equal to BC. Yeah, this is average energy density formula. You must revise this. I think we had learned this and learned this, but this is in the terms of B. You just substitute this as mu naught H, and then you will get the answer. So 1 upon 4 epsilon naught into E square, 1 upon 4 mu naught B naught square, equal to 1 upon 4 u mu naught H naught square. This is magnetizing field. Okay, you will learn, you might have learned this in the chapter electromagnetic, magnetism, sorry. In medium, the electric energy density is this thing, and magnetic in the medium, magnetic energy density is 1 upon 2 mu by B square. So the total is this thing, half epsilon naught E square plus half B square upon mu. Okay, and the contribution given by this, an energy or contribution of energy given by electric field and magnetic field is equal. So that is nothing like ये ज्यादा देता है कम देता है, दोनों बराबर एनर्जी देते हैं, तो उनका रेशियो 1:1 रहता है. 1:1. Okay, then we have the formula of, you must remember this formula. This is displacement current. The way of representing is, it has been changed a bit. So make sure you don't forget. So you must remember these formulas, okay? The radiation pressure is the pressure which is, exerted by electromagnetic wave. It is given by this formula, Poynting vector upon C. As the value of C is very large, so the value of radiation pressure will be very minute, very small. So we will consider it as very small delta. I have written just to tell you about that. And yeah, it will be S upon C for a absorbing surface, and it will be 2 S upon C for reflecting surface. So remember, when you will be given absorbing surface, then you will have to use S upon C, and for reflecting surface, it will be 2 S upon C. Then we have a representation of the wave, B equal to B naught sine kx by minus omega t, where this is amplitude, that is E naught, and this is also amplitude, which is B naught. Omega is angular frequency, which is given by this formula, 2 pi nu. Here, this is linear frequency, and this is k, which is 2 pi upon lambda. Lambda is your wavelength. So as this increases, nu will decrease, and also k will decrease. So intensity of sinusoidal plane EM wave is defined as average value of Poynting vector taken over one cycle. So the intensity of a wave, sinusoidal wave, is like that electromagnetic wave, is given by average value of Poynting vector. So average value of, when we take the average value of vector, a Poynting vector over one cycle, we will get the value of intensity. So we can basically say I equal to S average over a cycle. So basically इसके आगे आप average का symbol ऐसे लगाओ और S average लिख दो. That's the answer. So I think, guys, we are done for today. I have completed the chapter in the most easy and proficient way. Make sure that do comments on it. मज़ा आया होगा आपको, मुझे भी मज़ा आया आपको पढ़ाने में. I know I will be teaching in English. Sometimes I might forget some English words, so ignore it. Till then, wait for the next class. Bye. Bye. Peace out. Let's go. Ram Ram.